been shipping enterprise SSDs for a long time, and we actually put our enterprise class SSDs in space. Part of the challenge was to see how they would behave under potential radiation, everything that happens in space. And so it's the drives that are on the ISS are actually off-the-shelf KIOXIA drives, and we've had no problems whatsoever as long as it's in the ISS habitat. Now, there's other considerations once you go beyond that, where you don't have a stable environment where it's on the moon. So again, we want to have stable firmware. We want to make sure that everything runs well. So far, it's done great. We actually ran the first LLM, and there was a press release with Booz Allen Hamilton that we did about the first LLM that was run on Spaceborne 2.
Hello, everyone, and welcome to today's episode where we explore how AI, cloud, and data-intensive workloads are transforming storage infrastructure across Asia Pacific. I'm your host, Gerald David, Principal Pre-Sales Architect, APAC at Hewlett-Packard Enterprise. Now, with me today, we have a special guest, a person who breathes and lives performance, Tyler Nelson, who is the Senior Manager of Application Performance Labs at KIOXIA. Tyler and his team analyze workloads, and they analyze real workloads across AI, analytics, and mixed-use transactional patterns, and they understand how SSDs behave under real-world pressure. Now, together, HPE and KIOXIA have collaborated on delivering the next-generation storage for the most demanding environments. And this is from your AI deployments all the way to what you'll hear on the podcast, International Space Station. So Tyler, welcome. It is truly great to have you here today.
Thank you. I appreciate it. I'm very excited to dive into what we're seeing with SSD innovation. There are a lot of new things that are happening, and the entire industry is shifting. So it's very exciting to be here.
Awesome. Tyler, I like that you said that the entire industry is shifting. So let's start with the big picture. So what we see here in the APAC region especially is there's massive data center expansion, and it's driven mainly by the adoption, the level of adoption of AI, hybrid cloud, IoT, digital transformation. So customers are telling us that they are hitting performance ceilings now earlier than expected. Now, you're the person that works on this on a day-to-day basis. So from your perspective, what kind of workload patterns are shaping the designs that goes into, the SSDs?
So from a performance perspective, we see a lot of very strong trends. We're seeing, obviously, AI. Every application is trying to integrate AI in some way.
Yep.
A lot of heavy analytics workloads. We're seeing more and more data. Everyone wants to save more data. It's lasting for much longer. So a lot of those AI workloads have significant read pressure for training, but we're also seeing unpredictable block bursts with checkpoints, things like that. We're also seeing a growth in either hybrid cloud apps or edge apps that are really moving towards where we place the data. So the data locality, whether it's in a data center or at the edge or local to your business or in a cloud, again, that's all shifting, and it's becoming more and more hybrid, where you see part of the data live on-prem and part of it may live in the cloud.
Yeah.
So the patterns are shifting, and we are seeing a lot of mixed and dynamic I/O behavior based on the different applications and the use cases.
Nice. Wow. Okay. So you mentioned AI there. And look, I think we are all in agreement. AI has been, one of the biggest disruptors that we have seen in a long time. Now, what we are seeing, especially when we speak to our customers, is because of this evolution or this arrival of AI in such a big way, infrastructure being pushed not only from a compute, storage, networking, and cooling perspective. So I just wanted to get your thought. AI is pushing our workloads more so than anything that potentially has ever before. How is it changing the way that you evaluate, what goes into, the disk, the SSDs?
So from an application level and a hardware level, it's very much adapting in AI environments to maintain high sustained throughput, especially for the training side. So we want to keep those. There's significant investment in GPUs. So if we are going to keep those GPUs running, keep them fed with data, obviously the data sets are growing larger. So we want to make sure we maintain that sustained throughput. And also the tail latency control is becoming very important. It's been emerging with a scatter gather where tail latency is very important. But then as we move to AI, your checkpointing and other KV cache and other inferencing things actually need a pretty tight tail latency control.
Okay.
On top of that, we have obviously large burst writes. We are doing a lot of asynchronous checkpointing, so it's not as critical, but for vector index updates, we do have bursts of write. We're seeing very, very high queue depth. And when you're accessing data in parallel from many GPUs, a lot of those AI frameworks will create very high queue depth. So we're not necessarily just talking about, how many IOPS a drive has, right? That's more historical.
Yeah.
We're looking at, endurance. If we're going to write data and say caching data locally to have it as close to the GPUs, or we're going to bring it into a server from a data lake and then bring it in and out of GPU and then flush it. So then our write cycle is significantly higher for those type of things.
Yeah.
We're also seeing as we move to GPUs that are liquid cooled, there's a desire to move towards liquid cooling for SSDs as well. So that's going to be design considerations in the future is how do we liquid cool SSDs and, have very consistent, predictable behavior out of our SSDs and maintain that thermal envelope.
Well, that's some really cool tech there, Tyler. That sounds really nice. And I like that you mentioned, we still have customers coming to us and say, hey, how many IOPS can that particular drive? We are still having these classic conversations, but I like the fact that because of the emergence of AI, how real it is, that conversation now have to shift, right? So we no longer going, this drive can drive X amount of IOPS. It's more about what else it can do. And you also mentioned some cool tech, liquid cooling for SSDs. Well, I can't wait. I've been across storage all my life, so I can't wait to see the next iteration of this, which is going to be cool. Now, speaking of that, we will get into something which is, I guess, close to both of our hearts. You and your team test real-world workloads against KIOXIA's enterprise SSDs. And those are the ones that we use on our platform, which is the HPE Alletra MP. So you mentioned some innovations already, and we already implement that on the Alletra MP today. But what can we look forward to? If you can lift the lid a little bit, what can our customers look forward to in the next iteration of what you and your team are working on?
Well, obviously, as the workloads continue to evolve, we don't know. Obviously, agentic AI is going to change things.
Yeah.
And we're seeing PCIe 5.0 adoption across the board. So most storage arrays are sometimes a little slower than the direct server to adopt new SSDs. So we're seeing PCIe 5.0, the NVMe SSDs for faster performance, obviously up to 14.2 gigabytes a second of throughput. So we are seeing higher throughput on the drives. There's also obviously plans for PCIe 6.0 whenever those platforms and SSDs are available. So that will be on the roadmap further out. Right now, we're seeing adoption of new form factors. So in the server side, we saw E3S being adopted pretty quickly. There's still a lot of legacy 2.5 out there, and many people are still buying 2.5-inch SSDs. But we're seeing with Alletra and other servers. So the obviously the DL series is adopting E3S form factor, but with Alletra MP, we're looking to do E3S as well, and that can allow for higher density.
Nice. Long
term, there's also options for E3L, which is a little bit longer form factor than E3S.
Okay.
That's much, a little further out.
Yeah.
But that is something that we are developing in SSD, and we've announced our LC series that it comes in an E3L form factor, and that's actually a QLC design.
Wow.
So KIOXIA is now doing QLC SSDs. We've been doing TLC for many years. We actually invented NAND flash in 1987. But so we've been in the flash game a long time, and we're making TLC today. We're shipping TLC for high performance, but a lot of these workloads need super high capacity. you want cost efficiency for these data lakes or other very large implementations. We're actually showing a 245 terabyte SSD, a single device.
Wow.
Right.
Wow.
So from our standpoint, we don't want to just test things on a synthetic standpoint. We want to show vector databases, inference pipelines, all of these different operations and see how these drives work and how can we really enable the next generations of drives to meet the requirements of these workloads. So we really are looking for performance consistency and very good tail latency. And, obviously QLC is not as high performance as TLC. So depending on your workload, that's going to vary in what you want to put in your storage array.
Love that. So I can't wait for the E3L because what that means is we're going to get a lot more capacity, still brilliant performance. And it's actually exactly what our customers are asking us for. The demand has been a bit different, right? Especially with the as I said, I keep using this word, the emergence of AI workloads. Is just that people are demanding more in a smaller, denser space, right? Because of cooling and so on and so forth. Now, speaking of things like that, we, HPE KIOXIA, collaborated on something pretty special, and that's the Spaceborne Computer 2 running on the ISS. So that is a completely different ball game. I just wanted to get your thoughts, right? Like purely from an performance engineering perspective, right? The considerations that need to go into how we would design for space is completely different from what we design on Earth. So I just wanted to get your thoughts on that. What did that teach you, or what did that teach the KIOXIA team, like in terms of designing for the ISS?
So we have long built our drives for reliability, and so that's really, it's a different environment. And clearly, right now we're on the ISS, which has obviously space for the astronauts, and so it has air and everything else. When you start talking about satellites or going to the moon, which is on the roadmap, then that is a very different thermal requirement. The heat extraction, it becomes a significant problem because there's no atmosphere to actually, no air to absorb the heat, nowhere for the heat to go. So in a vacuum, it overheats very, very quickly. So getting thermal stability out of an SSD is a challenge. So we want to make sure that we have very reliable SSDs. We've been shipping enterprise SSDs for a long time, and we actually put our enterprise class SSDs in space. Part of the challenge was to see how they would behave under potential radiation, everything that happens in space. And so it's the drives that are on the ISS are actually off the shelf KIOXIA drives, and we've had no problems whatsoever as long as it's in the ISS habitat. Now, there's other considerations once you go beyond that, where you don't have a stable environment where it's on the moon. So again, we want to have stable firmware. We want to make sure that everything runs well. So far, it's done great. We actually ran the first LLM, and there was a press release with Booz Allen Hamilton that we did about the first LLM that was run on Spaceborne 2.
Brilliant.
So,
that's amazing, right? And I guess, Tyler, if it can perform in space, you should think it can perform anywhere in the world, right? Like, I mean, it's probably a given.
Essentially, that's the challenge. If it can perform in space, you can run it anywhere.
Anywhere, that's right. Yeah. All right. Let's bring us back down to Earth, right? Not everyone's going to go to space. So I guess not only do we bring it back to Earth, but let's focus on our customers in the APAC region. From your perspective, especially knowing what you know from a global perspective, you've seen the trends coming through. You've got a bit of that roadmap. Can I ask, what are some of the, actionable guidance that our customers here or enterprises here in APAC should focus on when they are planning for their AI and cloud workloads?
One of the things I really want to push is form factor. The EDSFF form factors are capable of higher performance, not only PCIe 5.0 today, but when we move to PCIe 6.0, that EDSFF connector and those designs, E1, E3, those are going to have the thermal and throughput performance based on the port that are really necessary for high performance workloads going forward. So
Yep.
we're hoping that there's more adoption of those E3 form factors
Okay.
to help drive that, because otherwise you're going to end up with bottlenecks with a traditional 2.5-inch form factor, whether that's thermal or just throughput on the connector becomes a challenge. One critical element is right sizing your endurance,
Okay.
right? So some data is worm data. Essentially, you write once, read many, right? So that is a good fit for like a QLC drive, a low endurance, like a 0.25, 0.3 drive write per day type of workload. Some other workloads are extremely write heavy, right? So there you're going to want like a mixed use drive. Make sure you have the right endurance for your particular workload,
Okay.
and understand. Beyond that is understanding the real world workloads, right?
Okay.
Test your workload realistically. Synthetic benchmarks are good in ways that you can estimate what it will be, but often they don't match up with what you see in the real world, right? Your particular database, like a standard like OLTP workload at 70/30 read-write mix may not be what you're running in production. So you need to evaluate your endurance needs for your storage.
Yep.
What does your workload actually look like? And then on top of that is matching the endurance of the storage to make sure that you're getting the right price point. Obviously, if your workload is very read intensive, getting a write intensive drive is going to be much more expensive, and you're not going to take advantage of that write endurance. So size the storage and the workload appropriately.
Yep.
And I think embracing that kind of hybrid approach. So QLC is really becoming popular, especially for extreme density, when you need massive capacity for data that's not going to be written frequently. So there may be a position there for a hybrid where your write intensive workloads go to like a TLC and then stage off, or other workloads go to a QLC layer. So we're seeing that tiering architecture really move into the NAND space versus a traditional NAND as the front end with hard drive as the slower tier. We're seeing QLC NAND be positioned for that high capacity and extreme density. The other part is making sure that your data is structured and positioned where you need it, right?
Okay. Yeah.
So you think in, what do I need this data for? Am I going to use it to train an AI? Do I need to, think about the pipeline and make sure that your storage strategy matches what you're trying to do with that data. So that is very much a key consideration for how the data is going to be used and where it needs to be landed and tiered.
Awesome. That really aligns well with what we have been trying to advocate with our customers. So you mentioned a few key things, right? Form factor. Think about that. That's quite critical. You're right about the 70/30. Most customers just go, yeah, give me that. That's usually what I've done in the past, but AI and other workloads have changed that dramatically. I also like the fact that you say, embrace that hybrid approach, ensure the right workloads sits on the right thing underneath, because what we are increasingly hearing customers saying, just give me a box that can do it all. And, we have constantly advocated that there's no one size fits all, right? Like I can't give you just a single box that can potentially do your AI pipelining as well as store things for your lake house, and then maybe do a little bit of Instarack. Like it doesn't kind of work yet in the real world. So I like that you've actually pointed out, hey, you're the guy from the engineering team, you know about this. Putting the right workloads on the right system delivers the best outcomes. We're very in alignment, because that's the kind of thing, as I said before, we advocate with our customers. This is a bit of a plug, but speak to the team at HPE, because we've been coached, trained in the way to help you identify the right type of storage systems for the workloads, whether it's AI pipelining, you want to do some instant rack, it's combining your data warehouse with your data lakes into a lake house, or you want some top level high performance OLTP type databases, we've got the right storage array for you. It won't be the one solution that fits everything, every use case. So thank you for underpinning that, Tyler, because it really gives a clear direction, right? That while we are moving to the age where it could be a cloud-like thing, but we do have to have considerations on what sits underneath so that we get the best results and best bang for your buck, especially now.
Right, and not everything is a file system access. Some workloads are best on a block level, fiber attached storage array, and then for certain workloads, object makes programmatically pulling in very large scale data is much easier in many cases on object-based storage. So how your data needs to be accessed, that's the great part about Alletra MP is you have a B10,000 or an X10,000. There are different versions to meet the requirements that you have.
Exactly. And thank you for highlighting that. Yeah, we do have specific solutions to address, unique problems or actually unique customer challenges, right? To help you get the right solution for your outcome. So thank you for actually underpinning that. I just had one, probably a bit of slight segue, but that's purely with regards to what we see right now with the market situation, with things being slightly uncertain. Advice for customers in the APAC region in terms of potential cost fluctuations. Is there anything that you would advise people from a cost perspective? What do we have to look out for? Or I just love to get your thoughts on that, Tyler.
Well, the interesting thing is we're not seeing demand slow down. Everyone is trying to drive forward with AI, and so GPU prices have been very high, and the demand across the board for storage to meet those GPUs has also been high. So that is just part of what's going on in the market today. However, I don't see anyone slowing down their AI deployment, right?
Yep.
So from that standpoint, it's going to continue to be a race for the best AI, and every application is trying to integrate it. All of the different vendors are trying to get AI integrated into all different kinds of platforms. So as that continues to drive forward, then that's going to have impact on the market.
Yeah, perfect. No, well put. And again, I think it goes back to this particular conversation that we're having. Right size it, know your workloads, and then just don't use historical numbers because the whole 70-30 read write, 60-40 read write, that goes out of the window with these new workloads, right? So no, thank you for that. And to our listeners, reach out to your HPE reps. As I said before, we've been coached, we've been trained to ensure that we are putting the right things to get you the right outcomes. Now, with that, Tyler, look, this has been a fantastic podcast. I truly enjoyed it. Thank you for being so candid with us. You've actually shared, real world insights, practical. Your advice comes from a position of knowledge because you've been in the lab. So we really thank you for that. Tyler, I just wanted to hand it over to you. Any last closing words before we close off the podcast?
No, thank you for having me. I really appreciate it. It's been exciting working on the Spaceborne program for the last few years and seeing the developments, and the entire market is really shifting. It's great to see massive changes that are happening as we try to adopt and figure out what these next few years, what these workloads are going to look like, and how AI is going to be used. So it's a very exciting time, and I really appreciate you having me on.
Tyler, that was fantastic. Thank you so much for sharing your real-world, practical, and workload-driven insights. Now, for our listeners, modern AI infrastructure, as you would have heard, is not about how many GPUs you can squeeze into a server anymore. It's about how efficiently you're going to move, store, and process that data. And you would have heard today that's how HPE and KIOXIA are working together to deliver that outcome for you. Now, thank you for joining us, and we will see you on the next episode.